Hello everyone. So today I am going to talk about another part of BLE GATT protocol implementation, that is how we can implement the peripheral role in our iOS app so that our app can behave like a peripheral for other central devices. So in my last video I have covered how we can implement central role in our app. If you missed my that video, I would request you to please watch that video before starting it. For that video, the link has been provided in the description box. So, in this video, I will cover how we can implement peripheral role in our application. So, let's start. So, in this video, I will cover is start up a peripheral manager object, set up services and characteristics on your local peripheral, publish your services and characteristics to your device local database, and fourth one is advertising your services, then respond to read and write request from connected central, and the last one is send the updated characteristic value to the subscribed central. So this is in order to implement the peripheral in your application. These are the uh, these are not just only the chapters. These are the six steps. First step is to create peripheral manager object, then create services and characteristic, and after that publish your service, and then advertise your service, and when you will advertise your service, then after you will able to get the you will able to get the request from the central for read and write, and then you can also respond to that service request, and then the last one is you are able to handle the update of for the characteristic values. So first is the creating peripheral manager object. The first step in implementing the peripheral role on your local device is to allocate and initialize a peripheral manager instance. You can create the instance by using following method. This init method, cb peripheral manager, and delegate and queue are the passing argument in this init method. And when you specify the dispatch queue as nil in the init method, the peripheral manager dispatch peripheral role events using the main queue. And after this initialization, you must implement the peripheral manager did update state delegate method to ensure that the Bluetooth low energy is supported and available to use on the local peripheral device. Actually, in order to show the runtime demo of the code, we need two devices. So I am unable to show here the runtime demo of the of the implementation, but I can explain the all the logic with PPT. But if you have any idea to showing it by simulator or by single iOS device, please let me know in the comment section. So in order to implement the peripheral role, the first step is to create a instance of cb peripheral manager. That is, in this init method, the of cb peripheral manager, basically there are two passing argument. First passing argument is cb peripheral manager delegate. Like here in my implementation, you can see here my peripheral class is implementing cb peripheral manager delegate, and uh, the second one is the queue. The second passing argument is queue, in which we need the peripheral role. So when you supply nil in the queue, suppose that you are supplying here the nil, like in my code, in my implementation, the peripheral manager dispatch the all the peripheral events in main queue. So like in this class I am passing nil here, so I will able to catch all the acknowledgement of peripheral related events in my current main queue. It will supply all the events in the queue where which is passed. If you specified any type of queue here, so all the delegate methods will be called on that queue. So when you will create the instance, it calls peripheral manager did update state, in which it let you know about current state of the connection, which I have already covered in my last video. So using those states, you can detect if the BLE support is available in your device or not. Like here I have implemented with a blank definition. So you the implementation is must for the developer. So here in this case, I am in my code, you can see I am passing the self as a delegate reference here, self as a delegate reference, since my current class implements CB central peripheral CB peripheral manager delegates, and Q as nil, because I want to listen all the peripheral related events in my current queue, that is my main queue. So so basic requirement to create service and characteristic is you must have a UUID for both. If you don't have those, you can create 128-bit UUID by using UUID gen command in the terminal like this. You will get new UUID as a response of this command. Then you can create UUID object like this, CBUUID, and you need to pass the UUID string uh, as a value. Why you should not use any rough UUID? Because if you try it, it will not supported by your device. The system will support the UUID, which is either predefined by BLE community or created by using UUID gen command. Okay, so my next step is how to create characteristics. So when you create a mutable characteristic, you set its properties, value and permission. I have covered the what is properties in my last video. So if you don't have any idea, so please refer to that video. You can create it by using following init method: CB mutable characteristic, type, properties, values, permission. The properties and permissions you set determine, uh, among other things, whether the value of the character is readable or writable, and whether a connected central can subscribe to the characteristic value. In the following example, the value of the characteristic is set to be readable by connected central like this. I am creating my characteristic is equal to CB mutable characteristic, and I am passing the character UUID and properties as a read property, and raw data with readable permission. So when you call init method of CB mutable characteristic, you need to call four parameters. You need to pass the four parameters. First is the instance of UUID here. First is the instance of UUID, and second one is parameter as a property, which indicate that if the central can read or write the data on the characteristic, or and third is the value, which is the raw data in this characteristic will contain, and the same will be and the same will be accessed by the central on the other side. And the last parameter will be, and the last parameter but not least will be the permission. What is the permission? Permission will indicate whether the central can subscribe it or not, right? So here in my example, I am creating a readable characteristic like this. like here you can see this characteristic is only readable but not subscribable because the permission is not subscribable. The next task is creating services. You can create a mutable service to associate the characteristic with it. You can create it by using following init method: cb mutable service, and passing argument is type and and primary. Type is cb UUID type, and primary is a flag of bool type. Example: let my service is equal to cb mutable service, and we are passing UUID service UUID as a type, and passing boolean true as a primary parameter. In this example, the second parameter is set to true. It's indicating that the service is primary as opposed to the secondary. What is primary? A primary service describes the primary functionality of the device and can be included by another service. And what is secondary? A secondary service describe a service that is relevant only in the context of another service that has referenced it. For example, a primary service of heart rate monitor may be to expose heart rate data from monitor's heart rate sensor, whereas the secondary service may be to expose sensor's battery data. After you create a service, you can associate the characteristic with it by setting service array of characteristic like this. Here I am creating the service as a cb mutable service, and then I am assigning array of characteristic to the characteristics property of the service. Now when we created the characteristic, we need to create the mutable service and associate our characteristic to that, right? So in order to create cb mutable service, I need to pass two parameters. First is the type, which is UUID of the service, and which should be different from the UUID of the characteristic, and another is the primary flag. If a service contains the characteristic which have data of primary functionality of our app, we should categorize it as a primary service by passing true in this flag. Otherwise the primary flag should be false. So after you create service instance, that instance have property called characteristics, which is basically an array of characteristics. So uh, when you assign an array of characteristic to this, those characteristic element will be associated to the service. We can say my service will contain those characteristics. So since a service may have contain more than one characteristics, that's why characteristic property is not a characteristic type, it is the array of characteristics. So like here you can see in this example what we are doing in this code. First of all, I am creating the UUID of service and UUID for the characteristic, and then I am creating the instance of peripheral manager like this, and then I am converting a string BLE tutorial into raw data, and then creating a characteristic for this, and that characteristic is a readable characteristic only. And then I am creating the service and with the service UUID, and this is the primary service, and then I am associating this characteristic to this service. Now I have created the service and characteristic both. Now I am ready to publish all the service and characteristic to the to my mobile system. So basically what is publishing. So next step is to publish them to the device database of the service and characteristic. Means that when you call add service method here, this is add service method. So when you call as add service method, so you are asking the peripheral manager to register the service and characteristic to the to system local database. When you call this method, so what the system will do, the system will register your service and characteristic in the local system database. So you can do this by calling the method of the peripheral manager dot add service. You need to pass service here. You can see this. When you call this method to publish your service, the peripheral manager calls this method of peripheral manager delegate. What is the method? Peripheral manager did add. This is did add. So it so when this when this insertion completed successfully, peripheral manager calls did add of the delegate, which is basically the acknowledgement of the publish request. So just a minute. Now after just a minute, yeah. So after publishing the service, the next step is to advertise the service. What is the advertising? Advertising the services is an operation after which your service and their characteristic will be available to all of the central for scanning and connection purpose. Right, this is the operation after which you are ready to read, and your characteristic and services are ready to scan and discover by all the other central. After publishing the services and characteristic, you can advertise your services to central by calling the method start advertising. So this start advertising is basically taking a dictionary as a parameter, and in order to advertise your service, you just need to supply UUID of that service. For example, in this example, I am just supplying this service UUID, and with the key CB advertisement data service UUID key. This CB advertisement data service UUID key is predefined key in the core Bluetooth, so you don't need to define it. Here we are advertising the service by passing UUID of the service. When you start advertising some of the data in your local peripheral, the peripheral manager calls peripheral manager did start advertising method of the delegate object. Here I have implemented this, and just I am checking for the error. If there is an error, it means the advertisement is not successful. Otherwise, it is indicating that advertisement has been successful. Once you begin the advertising the data, remote central can discover and initiate a connection with your peripheral. So just a minute. So you can achieve it by calling the start advertising function and pass your desired service UUID as a parameter through the dictionary. When you call it, the peripheral manager calls did start advertising function of the peripheral delegate as a acknowledgement of the process. So the next step after when you advertise your service and characteristics, so any of the central can access it, any of the central can discover it, and any of the central can make the connection to it. After the connection, any of the connected central can send the request for the read and write also. So when the peripheral get this request, so how the peripheral should respond for the read and write request, I am going to cover these things here. So when a connected central request to read the value of one of your characteristic, the peripheral manager call did receive read method of its delegate object, like this is did receive read method. In this method we are getting the property of cb at request object to receive from the delegate method, and that can be used to make sure that the characteristic of the request and the the characteristic of the request and our characteristics are matches. Now make sure that the read request is not asking to read from index position that is outside the bound of your characteristic value. Like here I am checking when the my peripheral is getting this request. So first thing is what I am doing, I am going to match the characteristic of this request to the UUID of my characteristic for which my peripheral is responsible. If if the UUID is same, it means that this request is for my peripheral central, sorry, so this request is for my peripheral characteristic. If this request is not for my peripheral characteristic, we should ignore we should ignore this. If it is for my characteristic, the next step is to make sure that this the cb the cb central is requesting the correct offset. What is the meaning of offset? I am explaining it in a few seconds. So if it is the valid request, then I need to then I need to response. If it is not a valid request, then I need to response as an invalid offset. If it is the valid request, then I need to first extract the data from our characteristic value for the given offset and then assign to the request dot value, and then I need to pass that request with the latest value to the peripheral with the success flag. If the success flag is indicating that the read operation of the central has successfully completed. The default value of the request dot value is nil. It means when you are getting the request, initially it don't have any value, so it is for the central to to assign some value here. So after you set the value, the respond to the remote central to indicate that the request was successfully fulfilled. When you receive the read request, first you need to make sure if the request is for the characteristic for which your peripheral is responsible. If it is, then only you should send the data for the characteristic, otherwise ignore, right? Since it is the limitation of BLE that you can send very limited size of data in one request, so oftenly the central tries to read big data in a chunk of request. Like here you can see the request has offset value. So why the request has offset value? Because there is a possibility that the central may request the big data in a chunk of small data, right? So so the so for in order to access the big data in a small chunk, this request may have the offset. It indicates the what offset value the request is going to access, right? So that's why the request contain offset property, and it is also indication that which offset central want to read. So as peripheral, second thing, we need to ensure that if central is requesting to read the valid chunk, so here like you can see here we are ensuring that this if check is ensuring that if the central is trying to access the valid data, if the chunk request is valid or not. If if it is not, then we simply respond as a invalid offset. Here I am responding as an invalid offset. If everything is fine, then we should extract the chunk of data from the characteristic. So what we are doing here, we are just making the range. Why we are making the range? Because I need to just extract that particular offset of the data, not a whole data, that particular offset of the data. And when I get that particular offset, I need to assign it to the request value, and after that I will send that requested value as a response to central device with success flag. Now that was how we need to respond for the read request, and now I am going to cover how we can respond for the write request. Actually, the responding of write request is just opposite of the read request. Let me explain how. When a connected central send request to write the value of one or more characteristics, the peripheral manager calls did receive write method. Here the did receive write method has a not have, has a single request. It has the array of requests. After you have ensured that the write request can be fulfilled, you can write the characteristics value like this, like we are doing in last slide also, right? After you set the value, respond to the remote central to indicate that the request was successfully fulfilled. All the 2 points are same as last, but the thing is the thing has changed here. So instead of we are getting the data from characteristic, and in last slide what we are doing, we are extracting the data from the characteristic and sending to the request. But here request value is not null. Request value has some data in the write operation, and we what I need to do, I need to get these data and assign to my characteristic, because it is write operation. So after completing this, uh, I need to respond to the central that hey, the write operation has been completed successfully. Okay, so since both read and write operation has completed, so now third operation is update update the characteristic value. So suppose that there are too many centrals which have subscribed a particular characteristic. So whenever the single amount of change is happening, so what should be happen, the peripheral should send the notification to central as a updated value, right? So how we can implement it, this is the in I am going to cover here. So the thing is that uh, when a connected central subscribe to the value of one of the your characteristic, the peripheral manager calls did subscribe to method of its delegate object, get the updated value of characteristic and send it to the central by calling update value. Here like here we what we are doing in this in this what is this in the did subscribe to method, what we are doing, we are just we are just make sure that if there is a this is the subscription of the the characteristic for which my peripheral is responsible or not. If it is the subscription request for that, then I need to extract the new data, and then the characteristic as a mutable characteristic, and then I need to call update value, and with latest data, characteristics, and array of central. So if my peripheral manager will call this method, so what the peripheral will do internally, whenever the new updated value is whenever there is a new updated value for the characteristic, so that value will automatically be sent updated to the central by using this method. So when you call this method to send the updated characteristic value to the subscribe central, you can specify which central you want to update in the last parameter. Like here you can say yes, if this as a parameter you are getting here the central, so you just need to create array and pass that central here. The simple approach is that when any central subscribe your peripheral, the peripheral manager will call did subscribe to characteristic function of the delegate. Here you can call the update value of for character. So that whenever the value of your characteristic will be changed, the your peripheral manager automatically send the update to the central as a notification. As you can see here, my latest data is BLE tutorial 1, not BLE tutorial, BLE tutorial 1. So I am sending the my latest data BLE tutorial 1 as updated data to the CB central, right? So in this video we learn how we can implement peripheral role also in iOS. So and in the next video I will cover any other IoT related topic. So if you want a video of any of the topic, either it is IoT or any of the topic which is related to iOS, so you can so please let me know in the comment section. And if you think that this video is added some value in your knowledge, so please like and share it, and don't forget to subscribe my channel and to get the notification for any upcoming video. Thank you.